Trigonometry, Unit 4, Main trigonometric ratios of acute angle. Remember that Pythagoras theorem, if triangle ABC is right-angled triangle at B, then AC squared equals AB squared plus BC squared. AB squared equals AC squared minus BC squared, and BC squared equals AC squared minus AB squared. Circular measure of the angle. The unit of measuring angle is called degree. 1 degree equals 60 minutes, and 1 minute equals 60 seconds. Example, if the ratio between two measures of complementary angles is a ratio of 3 to 5, find the value of each one by circular measure. Solution: two complementary angles are two angles. The sum of their measures is 90 degrees. First to second to sum 3 to 5, and 3 plus 5 equals 8, and put 90 degrees under 8. Then the measure of the first equals 3 times 90 over 8 equals 33 degree 45 minutes, and the second equals 5 times 90 over 8 equals 56 degree and 15 minutes. If triangle ABC is right-angled at B, according to angle A, line segment BC is called the opposite side, and line segment AB is called the adjacent side, and line segment AC is called hypotenuse. Sine of an angle. The ratio between the length of the side opposite to angle A and the length of the hypotenuse is a constant ratio called the sine of the angle A. Length of opposite side over length of hypotenuse equals sine of angle A. Cosine and tan or tangent of angle. Length of adjacent side over length of hypotenuse equals cosine of angle A, and length of opposite side over length of adjacent side equals tangent or tan of angle A. Trigonometry, Unit 4, Main trigonometric ratios of acute angle. Relation between sine, cosine, and tan of angle. For any angle theta, sine theta over cosine theta equals opposite over hypotenuse all over adjacent over hypotenuse. Cancel hypotenuse with hypotenuse. Then the ratio equals opposite over adjacent. Since tan theta equals opposite over adjacent, then tan theta equals sine theta over cosine theta. Example, ABC is right-angled triangle at C. AB equals 13 centimeter and BC equals 12 centimeter. Find the length of AC. Find each of the following: sine A, cosine A, tan A, sine B, cosine B, tan B. Prove that sine A cosine B plus cosine A sine B equals 1. And the last required, find 1 plus tan squared A. Solution. First step, you should find the missing side length in the right angled triangle AC. Since ABC is a right angled triangle at C, therefore AC squared equals AB squared minus BC squared. Therefore AC squared equals 13 to the power 2 minus 12 to the power 2 equals 25. Therefore AC equals square root 25 equals 5 centimeter. Now we can find sine A. Sine A equals, sine equals opposite over adjacent, then sine A equals 12 over 13. Cosine A adjacent over hypotenuse, then cosine A equals 5 over 13. Tan A equals opposite over adjacent, then tan A equals 12 over 5. Similarity, find sine B and cosine B and tan B. The third required, to prove that sine A cosine B plus cosine A sine B equals 1, solve the right side. The right side equals sine A cosine B plus cosine A sine B equals 12 over 13 times 12 over 13 plus 5 over 13 times 5 over 13 equals 144 over 169 plus 25 over 169 equals 169 over 169 equals 1, the left hand side. The last required, 1 plus tan squared A equals 1 plus 12 over 5 all to the power 2 equals 1 plus 144 over 25 equals 169 over 25. Example, XYZ is a right angled triangle at Z, where XZ equals 7 centimeter, XY equals 25 centimeter. Find the value of each of the following. Number A, tan X times tan Y. Number B, sine squared X plus sine squared Y. Solution. The right angled triangle XZY right angled at Z, and the length of XZ equals 7 centimeter and XY equals 25 centimeter. First step, find YZ. YZ equals square root XY squared minus XZ squared equals square root 25 squared minus 7 squared equals 24 centimeter. Number A, tan X times tan Y. Tan X equals opposite over adjacent, opposite to angle X over adjacent of angle X equals 24 over 7 multiplied by tan Y. Tan Y equals 7 over 24, then 24 over 7 times 7 over 24 equals 1. Number B, sine squared X plus sine squared Y equals 24 over 25 all to the power 2 plus 7 over 25 all to the power 2 equals 576 over 625 plus 49 over 1 over 625 equals 1. ABCD is an isosceles trapezoid. Line segment AD parallel to line segment BC. AD equals 4 centimeter and AB equals 5 centimeter, where BC equals 12 centimeter. Prove that 5 tan B cosine C over sine squared C plus cosine squared B equals 3. Solution: EF equals AD equals 4 centimeter, because the figure ADFE is a rectangle, and we draw line segment DF and line segment AE perpendicular to line segment BC, and BE equals FC equals 12 minus 4 over 2 equals 4 centimeter, because triangle AEB is congruent to triangle DFC. And we can find length of segment AE equals DF by Pythagoras theorem equals square root 5 squared minus 4 squared equals 3 centimeter. Now we can find value of 5 tan B cosine C over sine squared C plus cosine squared B equals 5 times 3 over 4 times 4 over 5 over 3 over 5 all squared plus 4 over 5 all squared. The value equals 3. Example: ABC is a right angled triangle in B. If 2AB equals square root 3AC, find the main trigonometrical ratios of the angle C. That's mean sine C and cosine C and tan C. Solution: the ratio between AB and AC equals root 3 over 2, because the product of extremes equal product of the means. Now we can find BC. BC equals square root 2 power 2 plus root 3 power 2 equals 1. And now we can find sine C and cosine C and tan C. Sine C equals root 3 over 2, cosine C equals 1 over 2, tan C equals root 3 over 1.